So hi and hello, welcome to our channel named Algo Exploration. My name is Samir and in today's lecture we will going to learn how to represent omega notation. Now before that I have shown you how to represent the bigger notation. Bigger notation was used to represent the upper bound of an algorithm, but here omega notation is used to represent the lower bound of an algorithm. Now let me show you how to find the lower bound of a program. This is a piece of code. It says when the number is even, then it will just print the number. But if the number is odd, then it will print the first and natural numbers 1 to n. Now if the number is even, this will run, which will take constant time. But if the number is odd, then this will run, which will take n time. Now comparing both of them, this will take higher amount of time when the number is odd. This is the actually upper bound of our program, so we will use order of n. Now this will take a constant time if the number is even, so constant means 1 only. So to represent this we will use omega notation. So in this way we calculate the lower bound of a program. Now the definition of an omega notation is f of n is equals to omega of g of n if and only if f of n is greater than c into g of n for all n greater than n naught, such that there exist two positive constants, c naught should be greater than 0 and n naught should be greater than 1. So if f of n is a function, c into g of n should be lesser than f of n. Here it is a n naught, which will be smaller than n. Now let's solve some problem based on omega notation. Now this is a problem. This is our first question. Here f of n is n square and g of n is n square plus n plus 5. Now according to the definition, f of n should be greater than equals to c into g of n. Now I have shown you how to calculate this equation. Substituting the value of f of n, it will be n square and g of n will be n square plus n plus 5. Now value of c should be greater than 0. Now if we put value c equals to 1, then it will not make any sense, because n square, this term should be greater than this. So if we put c as 1 or 2 or 3 and so on, it will not make any sense. So we have to take c as 1 by 2. So let's take c as 1 by 2. N square is greater than equals to 1 by 2 n square plus n plus 5. Now let's take n as 100. So this will be 10,000 is greater than equals to 10,000 plus 100 plus 5 divided by 2. Now this will satisfy the equation. Now let's find the value of n naught. We have to put n naught value in this equation. N naught equals to 1. 1 square is greater than equals to 1 by 2. 1 plus 1 plus 5. So condition is false. Right hand side is greater. Now let's put n naught as 2. 2 square is greater than equals to 2 square plus 2 plus 5 divided by 2. Again false. Let's put n naught as 3. 3 square is greater than or equals to 3 square plus 3 plus 5 upon 2, which will give us 9 is greater than or equals to 9 plus 3 plus 5. So this will be 8.5 and condition is true. So when c equals to 1 by 2 and n not equals to 3, f of n is equals to omega of g of n. Now I highly recommend that please watch the previous video to see what's going on actually. Now let's calculate this next question. Here f of n is n plus 5 and g of n is n minus 5. So let's substitute in f of n is greater than c into g of n. N plus 5 is greater than or equals to c into n minus 5. Now if we observe this equation, it is actually true because n plus 5 is greater than n minus 5. So when c equals to 1 and n not equals to 1, f of n is equals to omega of g of n. Let's calculate the next question. Here f of n is n plus 5 and g of n is n. Now we can see that for this condition f of n should be greater than or equals to c into g of n. F of n is actually bigger than or we can say larger than g of n. So therefore we can say that f of n is equals to omega of g of n. Now in the next lecture we will see the theta notation, which is a combination of lower bound and upper bound. So thank you.